Welcome to a little tutorial on how to balance chemical equations. So we'll go through this and a couple other examples from your homework for tonight. This is question number 1. And first thing you need to do when you're balancing chemical equations is you have to look at which elements are on either side. So I like to do a little dotted line down the middle right here. And I analyze the reactants and the products to see which of each I have. So on the left-hand side, I have a hydrogen atom, and I also have an oxygen atom. So I'm going to write those both down. Now on the right-hand side, I'm going to have, no matter what in a chemical reaction, because of the preservation of mass, the preservation of matter, I'm going to have the same chemicals or the same elements on the right-hand side. Okay, so I'm going to have hydrogen and oxygen. Now, even if they don't appear in that same order on this right-hand side, I'm still going to write them in that order, and you'll see that on the next couple of examples as well. Now, a big thing that a lot of students have trouble with is recognizing, okay, which one of these are actual elements. You don't really have that issue here, but as we move on, you might say, okay, which of these letters is an actual element? Remember that elemental symbols will always be 1 or 2 letters, and they must start with a capital letter. So if there are 2 letters together and they are both capital, they are both their own elements. Okay, so if you see C, capital C, lowercase d, that's going to be not going to be carbon and something else. Well, there's nothing that has a d, but it's not going to be carbon and something else. It would be cadmium. Okay. Versus if you have two capital letters like O and H, it's going to be oxygen and hydrogen. So you have to be sure that those are distinct. Okay. So now the next thing is, all right, let me count my atoms of each of these elements. So on the left-hand side, I see this H2. Now that is representing a little hydrogen molecule that looks like this. It has 2 hydrogen atoms. Okay, so I'm going to count those up and put them right here. Similarly, I have an O2. That is also representing this diatomic molecule of oxygen that has 2 oxygen atoms. Okay, now on the right side, I've got this H2O, which means I have 1 oxygen atom and I have 2 hydrogen atoms, just like that. So this little subtext is referring to the letter to the left of it, which hopefully you remember from a little bit of the work we've done so far. But that means I have 2 hydrogen atoms and 1 oxygen. So I can go ahead and count those all up as well. So now what I need to do, my goal here is to make all of these numbers equal each other. Already, I see hydrogen and hydrogen are equal to each other at 2 and 2. That's great, except for oxygen and oxygen aren't, right? I have a 2 on the left-hand side and I have a 1 on the right-hand side. So I have to figure out how to remedy this by making those numbers equal. Now, you might say, well, what if I just chuck a 2 right here? And now I'm, all hunky-dory and I've got 2 and 2 on either side. Well, that would be great, except for you are not allowed to add more subtext or insert more subtext into a chemical equation. This changes our molecule from water, which is beneficial and absolutely necessary for us to live, to hydrogen peroxide, which if you consumed it like you consume water, you would die. That is a bad thing. We cannot insert the subtext like that. Instead, what we have to do is we have to insert, and I'm going to, erase all these values. We have to insert what's called a coefficient. That is the number to the left of the entire molecule, like this. I'm going to insert that as a 2 because that coefficient is multiplicative. Now there's an implied 1 right here that says there is 1 oxygen atom. Now what I'm doing when I insert that coefficient of 2 is I'm saying there are now 2 of these molecules. So there's another molecule right here that is an H2O molecule. So now as I recount my atoms, which every time I insert a coefficient and I recount my atoms. So now I have 1, 2, 3, 4 hydrogens. So I'm going to cross that out, rewrite it. And now I have 2 oxygens. Okay, so now my oxygens match, but now my hydrogens do not, right? So I'll go to the other side, the left-hand side, and I will insert a coefficient there. The 2 in front of the H2, remember that this is multiplicative, so 2 times 2 is 4. Now, that's why I chose 2 here, is because I knew that 2 times 2 is 4. That means these match and these match. That is now a balanced chemical equation, okay? So anytime when I inserted this 2, what I did is I didn't say there's now a molecule that looks like this. That is incorrect. Instead, what I said is I have 2 of these HH molecules, okay? And then I can recount their atoms. All right, that's what that coefficient is doing. All right, so that one's balanced. So let's look at another example. We have FeS2Cl2 goes to FeCl2, S2Cl2. So on this left-hand side, I'm going to write these atoms down in the way that they appear. So iron, sulfur, and chlorine, okay? And even though they don't appear in that same order on this right-hand side, I promise you it will be easier to keep track of things if you write them down in the same order, because then you're just comparing left to right, the numbers, rather than trying to look diagonally, and it gets very, very confusing. So write them down in the same order on the right as you did on the left, and now let's count our atoms. So step 1, count the atoms. Iron, I only see 1 iron atom on the left. Sulfur, there are 2 sulfur atoms on the left, and chlorine, there are 2 chlorine atoms on the left. I'm going to erase those just so that we can see clearly. Now let's count the right-hand side. So iron, I have 1 over there again. Sulfur, I have 2 again. But now chlorine, see that chlorine is with this iron atom and with the sulfur atoms. So I actually have a total of 4 chlorine atoms, okay, because there are 2 with iron, 2 with sulfur. All right, now I need to figure out, okay, how do I make these things match? Well, first thing I see is that my chlorines and my sulfurs, well, actually my sulfurs do match, so just my chlorines don't match. What I can do is I can actually, on this left hand, this is a diatomic molecule, all I have to do is just insert the coefficient of 2, recount my atoms, and now actually everything matches, which is real nice, okay? So all I have to do is insert a coefficient, that's the only one I have to do, and I'm good there. Okay, now a lot of people will ask, do I need to insert a 1 here to say that I have one of those molecules? You don't. You just need to understand that there is a 1 there. So the first coefficient I add, like right here when I added that or inserted that 2, I didn't say this was 1 and now I have 4 chlorine atoms. Okay, I didn't say that. Instead, I understand that there's an implied 1 there and the first coefficient that I'll insert is 2, saying, okay, now 2 times 2, that gives me 4 chlorine atoms. Okay. All right, let's do one more for right now. This one's a little trickier, and we'll have a couple of really great things to go from for this. So the next one, we'll go ahead and draw our dotted line, and I'm going to write the atoms in the order that they appear on the left-handed side. So I've got magnesium. This is what we were talking about earlier. Those are both capital letters, which means they are their own element. So I've got a capital O, capital H. I have an H again over here. I do not need to write that twice. Okay, I'll count it, but I don't need to write it twice. And chlorine. Okay, I'll write those down in the same order on the right-hand side as well. So now that I've got all those written down, all I need to go through and do is count the atoms. So on the left-hand side, the reactant side, I have 1 magnesium atom. I have, oh, look at this, a parentheses with subtext outside. Now when I have that subtext goes to both of these because it's saying that I have 2 of those little polyatomic ions that are with the magnesium ion. Okay, so what I have to look at is I have to say, okay, there are 2 oxygen atoms and there are actually 2 hydrogen atoms represented right here. Now when I'm counting hydrogen, I need to not forget the other hydrogen that's a part of that hydrochloric acid molecule. So I'm going to count those as well. So I'll have 3 total hydrogens and 1 chlorine atom. Okay, now on the right-hand side, I'm going to count them all as well. So I've got 1 magnesium atom, I have only 1 oxygen atom, I have 2 hydrogen atoms, and I have 2 chlorine atoms, or chloride ions if you'd rather. But what I need to look at now is, okay, I've got a lot of mismatching things here. The cardinal rule here when balancing chemical equations is you want to try to leave the simplest chemical equations for the end. So the thing that will disrupt the least number of atoms, basically. So a thought here is, okay, well, let's just try some things, and this will actually just take some trial and error for you to become well-versed in it. First thing I see right here is I see that chlorine and chlorine don't match. So I'm actually going to insert a coefficient of 2 here and then recount my atoms. So my chlorines go to 2 on the left-hand side. Now my hydrogens, though, I have now 2 in this molecule, but I still have these other 2 in that first molecule. So I'm going to count all of them and say, now I have 4 hydrogen atoms, okay? Now I see oxygen, oxygen doesn't match, and I see hydrogen, hydrogen doesn't match. On the right-hand side now, I'll need to insert a coefficient of 2, and actually that solves both of my problems because now when I count those, I get 2 oxygen atoms and I get 4 hydrogen atoms. Okay, so that's a rough tutorial so far. In a little bit of time, I'm going to reveal some bonus questions, so hopefully that will help you with the rest of your homework. But go ahead and start working on your homework and get after it.